Which brings me to the content part. We have now Mainte Boersma, who has been doing language and particularly domain-specific languages stuff for quite some time, written a book about it, and is now talking about how to make a domain-specific language for non-devs so they don't need AI. And I think that's really a good point in time, because I have all my colleagues that say, oh no, now we can just tell people to use AI, and whatever comes out of AI we throw into our software and everything is great and nobody understands anything anymore. So please give us a more controlled way, Mainte.
Good afternoon. First of all, this title reads as how to make a domain-specific language for non-devs. So it's not how to make a domain-specific language and that non-devs can do it. It's you still doing the deving, but it happens to be for non-devs. So the Herald already said this. Basically, I've been doing this stuff since 2007, and my company name is DSL Consultancy. A couple of my customers are the Dutch tax agency. I've done quite a bit for the Dutch Ministry of Health around COVID certificates, and currently I'm working for a German laser manufacturer. A little bit more about that later. So, quick survey is, are we hungry already? Okay, that's not what the survey is about. Also not about washing hands, etc. Has anyone tried to actually write and develop software using AI, ChatGPT, Copilot, hands? Okay. Of those hands, how many of those hands enjoyed that experience? Okay, about half and then half again. Yeah, that's what I figured. Have you ever seen anyone, a non-dev, trying to make software using something like ChatGPT? Okay, how painful was it to watch? And how painful were the results? Like way up there, over 9,000, etc. Okay, I figured that as well. So it turns out generative AI and software development are maybe not the best match ever. Even this week I saw a couple of articles, one from Martin Fowler, where they tried to do like really simple stuff, really basic stuff with, I think, Copilot they used, and it was not good. Anyway, I'll do a quick rant on AI. First of all, there's old AI, an old AI for the older people amongst us, to which I count myself as well. Things like expert systems, logic program, Prolog, digital processing, and especially neural networks, machine learning. Earlier today we saw a talk about birdsong, which actually used the right kind of AI, namely machine learning and neural networks. So this is a very simple neural network. You have an input, you have some hidden layer, you have an output, and these neurons basically sum their inputs, and there are weights on these arrows. And you train these networks by throwing lots of inputs at it, and then you carefully adjust those weights so you get the desired output. By the way, I'm not an AI expert, so this is mostly uninformed. But that's how neural networks work. So essentially, it's applied stochastics. And this works great. I mean, you can recognize, you can make a Shazam with it, and even can make a Shazam for birdsong with it. That's great. So you also have the new AI, which is generative AI. And what you do there is you basically turn the neural network around. So you say, okay, I trained a large neural network, and now I want to have something that would give me the following output. So you specify the output, and you try to turn it around and see what kind of input you can come up with for that output. So it's a reverse neural network. The thing is, you have to throw a lot of dice. in that process. There's a lot of random stuff going on. Hence, the stochastic parrot. So and the hallucinations, and that's where you get all these hallucinations from. It's still random. It's still parroting back what you trained it with, but random stuff. LLMs are a little bit smarter than that with token transformers, etc. But it's still basically a stochastic parrot. So I saw this one last week. It's Pareto's AI law or result. Well, yeah, 80% correct 20% of the time, 20% correct 80% of the time, and you still don't know which one of the two cases you're hitting. And even if, for example, ChatGPT is claiming it gets 80% more accurate in the next update, okay, those percentages go up a little bit in your favor, but still, you don't know what's going on effectively. So, that was the rant. Now back to, we want to do software development by, or actually for non-devs. So a non-dev is a non-technical business person. So someone who has a job to do, uses a lot of a lot of IT for that, and wants to have software for that. They probably are working in some kind of domain, and domain is a particular focused area of knowledge. So, for example, my current employer is a laser system manufacturer, and they make laser systems, and they hand them over to a customer, and this customer can program all kinds of shapes, and then have them cut out of metal. Very, very nice stuff, very, very high tech, etc. So that's the domain of laser cutting in this case. A little bit more about domains. Hopefully you can also see the vertical one. It's a bit the purple one, yeah. So in general you have horizontal and vertical domains. Horizontal is like the technical, the developer-centric stuff, and the vertical stuff. The vertical domains are like the business kind of thing. So horizontal things are like infrastructure, like databases and such. A vertical is that just cuts through all these technical layers and just gives you is about giving you a business application. So I'm mostly interested in business domains, so in vertical domains. The technical stuff is also very interesting, but in business, if you have your vertical domain is basically your crown jewels. That's where your competitive edge will be. So let's say you are a non-dev and you want to make some software for your domain. You have a couple of options. You can use Excel, and that's actually what a lot of non-dev people are doing. Like I think probably 50% of all software solutions on the work floor in businesses are like Excel. Okay, you can also hire developers, but that's scary, obviously, because then you get all these hacker types, etc. You can also use a no or a low-code platform. It's also a good option, and you can also become a dev yourself. Well, option 4 is never going to happen, obviously, and we have a new option, and that's the new option 1 is ChatGPT. So the question is that very useful? Well, the thing is, you're working in your domain. If you're in a business and it's your crown jewels, that domain, so it's your competitive edge, what would be the chances that ChatGPT is trained on your domain in such a way that you can come up with a prompt that actually understands your domain well enough, and that you can have ChatGPT come up with a piece of software that works for your domain? I already see some shakes there. Well, there's one reason why that might work. If you had a security problem and you got hacked, and then the Chinese, for example, trained their LLM with it, then you might have a good chance that this actually works. But it's probably not what you want anyway. So, that's one reason why this is not working very well. The other reason is that ChatGPT is trained on basically on solution domain stuff. So ChatGPT can do if you say, okay, I want to have a program in Python that sorts a list or something like that, fine, works fine. But that's already very developer-y. So these non-devs will probably not be able to come up with a prompt that spits out working software for their domain because they don't know how to phrase things in the solution domain. Right, so is there a better thing? Well, we can revise option 2, and that's the much more fun option. You can have developers craft a domain-specific language. So what is a domain-specific language? It is a formalized language or a formal language that supports a specific domain, so no surprises there. But the good thing is DSL supports its domain experts, so the people inhabiting this domain, by empowering them to capture their knowledge, their crown jewel knowledge, so to speak, in a precise and unambiguous way as DSL content. So what is a software language then? It's a bit vague, but it's basically a collection of tools to write stuff in this language and so with an editor and compile it or interpret it, so basically run it and maybe do some linting and build a software development process around it. So, okay. We know of examples of DSLs. Well, actually, in the previous talk we saw kind of an example of a DSL, which is the Final Fantasy script language, right? Yeah, that's a DSL. I think that counts as a DSL. Any other examples that people can think of? Just shout out, but loud. SQL is a good one, yeah. Is it horizontal or vertical? Yeah, very horizontal. SQL is very horizontal. Other examples of DSLs that people know? Yeah, also horizontal. Elasticsearch is a horizontal DSL. Yeah, that's Oracle, right? I think. Yeah. So yeah, Open Policy Agent. Yeah. Also maybe vertical DSL that we know of. Ooh. Yeah, I know it, but I think we're only 3 people in the room. Yeah. Exactly. Yeah. Music notation itself is a very good example of a DSL that's age-old and predates computers, of course, by centuries. Sorry, Okay, I didn't get the reference. We'll talk about that later. So yeah, I have an example that I worked on. So I worked for a bit at a Dutch tax agency, and there we built a tool called Aleph, which stands for Agile Law Execution Factory, and that's actually a bunch of DSLs together. And one of those DSLs is regelspraak, which is rule speak. And that's a way to phrase tax law as controlled Dutch. So these sentences you see on the left, yeah, I can't point unfortunately, but here the left pane, these sentences are rules. So they act on some input, and then they draw a certain conclusion, and the conclusion is in the form of an effect, like, okay, yes, this person has to pay tax indeed, and and then other input is, the person has so many jobs, so many children, so, and then all this is through various rules used and combined to come up with the eventual numbers that they have to pay. And the fun thing is, the domain experts here are rule analysts. So these are definitely non-developers. And they were already used to regelspraak, to this rule speak, before they got this tooling from us. So it's a standard that was already present within the Dutch tax agency for years and years. And we basically just made the tooling for it, so they could actually type it in, and it actually meant something. So each year the tax law changes, and these rule analysts, they will just go through the changes in the tax law, see what they have to change here in these tax rules that are a bit more precise than a tax law itself, and they can do that without any developer helping them or checking stuff, etc. So one of the other DSLs that's within this Aleph tool is a DSL to specify test cases. So you can just check, okay, I have this rule, let's make a test case for it and see whether it still behaves the same way as it did last year, or if there's a change, okay, now it has to behave in a certain other way. So they can do all the test work, etc., perfectly themselves. So for I think 8 years, there's just no developer involved with updating the income tax calculation, the final income tax calculation in the Netherlands. So there's not a developer that is asked at one point to, okay, we have this rule now convert it to Java or whatever, and then we can update our software as well. Now, this is all done by the non-devs, by the rule analysts, and that's actually deployed in production. So that's the funny thing here is that most domains already have a sort of a DSL. So we see it here with rulespeak, with the regelspraak. But in general, most domains will have like their own dialect, their own way of wording things. So in most domains, the DSL is already there to some part. So for us devs, the effort that you have to make is like extract that from the domain, talk to people, look at documents that they've written, and then start formalizing this DSL and making tooling for it. So why is a DSL a good idea? You can get work done a lot quicker with a DSL than if you have to talk as a business person with a developer and explain them the domain and explain them what to do, and then they have to program everything, etc. If they can do it themselves, it's much easier. It's much more fun. And certainly for the developer themselves, by the way, but also for the non-developer who are much more empowered by this. One of the best reactions I ever had for presenting a DSL to a colleague was, okay, now if you can move over, then I can finish my job with the stuff that you've just shown. That's a very good reaction to have. Second of all, there's much less room for fuck-ups and developers going creative and things like that, because your DSL can only do so many things. It's not a general programming language. It has a very narrow scope of what it tries to achieve. Third advantage is you can also reason about the domain knowledge a lot better, because you have code that is not code, but is actually good enough as code, that you can, for example, query and run like change impacts on, or see, if for example with the tax agency you can think of, okay, maybe we want to run a whole set of test cases and see if we can change some things that we have a certain advantage for a certain group of people, things like that. And also, the dev work that you will have is much more interesting than if you had to do it yourself, because you can do meta dev work. So, why does this work so well? Well, one of the things is a DSL can be, it's a small, usually quite a small language, so it's not a very big general programming language type thing, but it's usually quite a small language. As for example, I've seen with Nicky's talk, it's like 20 commands or something like that. But it gets interesting when you have expressions. So expressions are, well, logic expression, arithmetic expressions, all these things, they tend to be arbitrarily complex. Like you can nest arithmetic expressions inside each other, etc. So you can make them as complex as possible. So this technical word is, I think, a recursive language for this. So once you have expressions, things get really interesting really fast and really powerful really fast. The other thing is references, and we of course we know references. We as developers, we know references, but a lot of non-developer people have no idea that there's such a thing as a reference, and that you can maybe just take some code out, which is not code, but take some code out, put it somewhere, put a name on it, and then reference it from some other place, so you can reuse it without having to copy-paste it. That's. I mean, for us, it's obvious that it exists, but for non-developer people, that's really a new thing. So, why is this better than? One of the great things of having a DSL and having your domain experts actually use that for their everyday job is it provides a basis of shared communication. Earlier today I saw in the library the domain-driven design book by Eric Evans. I guess a lot of us will know that. That's also all about this shared language. And with a DSL, you have that in a tooling-based form even. I mean, you'll get a compiler or an interpreter or something like that for it. That's great. I've seen it working with my current assignment, where they were making software in like 10 teams, and so in effect you had like 10 pieces of software that had to communicate with each other, and it was a bit of a mess. And now everyone is using this DSL that we made. And all these small translation problems, like if we say left, then it's or if we say straight on, then it's actually to the left. But this other team that has another idea of where things are going, and this makes stuff just so much easier. Second reason is DSL content is at least as good as high quality code usually. Also not unimportant, it has a better CO2 footprint than using ChatGPT to come up with stuff. And you don't have to share your trade secrets with ChatGPT or Copilot or what have you. I mean, if you try to learn an LLM, your domain, inevitably your domain will sort of leak through to the training of this LLM, which is probably not a good idea. Definitely also situations where you don't want to use a DSL, because all these things have limits. It takes a bit of time to implement this DSL. It takes a bit of effort. It's worth it in the end, usually, except for if your domain is too small. If there's just not enough domain knowledge to be captured in this way, then don't do it. Also, if your domain is too simple, maybe find a different solution. Or if your domain is too irregular, like there is a sort of a balance between how many concepts are in your language or in your domain, and how variant is your DSL content. Is everything a special case, or can you capture like 90% easily with a couple of concepts? So if everything is a special case, yeah, maybe then it's also not a very good idea. Okay. So let's get a little bit more into details. So there's a couple of key aspects to a DSL. There's structure that basically says, yeah, okay, it's like a type system. It's like your set of classes that describe what is possible, what is in theory possible to describe with that. Then you have, of course, you have notation, like how is the stuff written down. You have meaning, also called semantics, and that's basically how do you run this stuff. And you have constraints, And constraints is, okay, I can describe certain things according to the structure, maybe, but if I try to run that, then the runtime will blow up or something like that. And that's where the constraints come from. So this is a picture of that. Yeah, really doesn't work. Pointing doesn't work. Let's go. So, okay. I guess most people have mainly seen textual DSLs, I guess. Right? I mean, SQL is one example that is very, very textual. There's loads of other examples like CSS, HTML, etc. That's all textual. So this is a very quick picture of a very simplified picture of how a textual DSL works. You start off with some plain text document. You load it in a text editor, and to be able to do anything with that meaningfully, you have to parse that text, right? And then you get a parse tree. Then we have those pesky references. Well, they're very useful references, but in a textual DSL, you actually have to resolve these references, and maybe you want to tidy up your parse tree a little bit as well. And then at the end of that process, you get the abstract syntax tree, so the AST. And that's basically your very useful thing to have, because then you can reason that's nice and clean, and you have references, and you can really reason about that. And that you put into things like constraints checkers, semantic highlighters, and content assist compilers, interpreters, linters, the works. So that's really your centerpiece, but it's kind of hidden because what you're seeing is this text in your text editor. So if you're exposed to academics, then they tend to say parsing is a solved problem. Well, yeah. Technically, rocketry is also a solved problem. Yet things blow up sometimes. We hackers seem to be very keen on finding new and interesting ways to blow things up. So I don't think that's a very good argument. And I definitely see some challenges with parsing. I guess you're familiar with, you have a nice document, no red squigglies, no errors. You type one character and all of a sudden, at least the rest of your document is all red, right? So error recovery is a big thing for parsing, like that your parser doesn't crash immediately out when you have one thing that is slightly wrong. Ambiguous languages, how to deal with that. Horrible parse trees, because it's just what your parser technology will allow. Recursion is often a bit finicky to deal with. For example, has anyone ever had to left factor and a grammar for LL star type parsers? Yeah, exactly. I see already 3 or 4 hands. And of course, performance is also a thing because you have to reparse your document every time you change the document, right? So you get this editor lag where it has to go through this entire pipeline. So it can very well happen that you type some stuff and then at some point your constraints checker is finally gotten its hands on this AST and will report you, oh yeah, that thing over there that you already had finished typing or whatever has some errors. Yeah, of course, I fixed those already, but the performance was not very good. So and you have all kinds of nice parser technologies, but very powerful ones. But the more powerful they are, the more difficult they seem to be to debug. So this is the Brian Kernighan quote for it. Okay. But the main problem is the non-devs, the non-techies, they just run away. If you try to get them to use plain text stuff, they just run away. So is there something better? Yeah, I think there is. It's called projectional editing. It's actually been around for quite a while, at least a couple of decades. People might also know it as structural editing, or structured editor or editing, whatever. I like projectional editing. So, And the idea of projectional editing is we flip this whole thing around. We don't start with plain text or something like that. We just start with the AST. And what we do then is we project this AST using a projection to some kind of notation. These days, of course, it has to be in a browser, so it's fine. So this projection is just projected in a browser. And then simultaneously, you can also run the constraints checker and have something like content assist, etc. And whenever the projected AST is changed, and we'll see how that works in a bit, then you just change the AST from which this all originated, and then everything goes to the pipeline again. And this is much simpler, and also usually much more performant, or easily much more performant. Okay, a little bit of demo. Was already mentioned that I wrote a book about this. Usually I have books with me, but my stuff is in storage, so I couldn't bring one. But you can scan the QR code. And the demo I will show is actually code from the book. Hopefully that works. That's the one thing I didn't check, of course. So in the meantime, that's a bit of pity. How can I? No, eh? Okay. Right. I'm not sure how I'm going to fix that. So maybe people want to come around afterwards. I'm also, I have 10 minutes still, or thereabouts, yeah. Yeah, maybe I do want to fix this. Maybe we go back a bit. Yeah, so I can talk a little bit more about this. So unfortunately, apologies for that. I'm not getting the demo to work right now. Are there, at this point, any questions? Any poignant questions? This is the part where my question was earlier about, are you hungry already? Yeah, I guess we are. Yes. Yeah, I can.
Are you going to continue? Or
yeah, I'm going to continue, okay. But I want to give people at least some.
So I understand what the final result of this, which is a DSL. What is the development lifecycle of a DSL? How do you iterate with your clients or with your users?
That's a very good question. Yeah, so a DSL is actually a collection of tools. What you typically deploy at a customer site is an environment where they can edit their DSL content, so where they can edit their ASTs, although they will never see it as AST, but they will only see this projected AST, this DSL content. And then afterwards, you have a choice between, for example, making an interpreter for your DSL content to run it, or maybe compile it using code generator to some other platform. So that's where you have a choice. You can even do it simultaneously. So have both options for your customer. But yeah, you have a lot of options and a lot of choice there because you decoupled the cycle of authoring your DSL content from the technical solution. So you just have something that the domain experts can use to capture their knowledge with. And then as a developer, you can choose, okay, what's the best way to deploy this? And you're not bound by any choices at that point already made. So that's a very good thing to have. Also, you tend to evolve this DSL. You start out small. You start out with a small DSL that captures maybe a part of all the domain knowledge, and then you build it out, you extend it, you expand it, and that works also quite well with this, because you just give your domain experts more and more possibilities. For example, with more expressions and other stuff they need to be able to do. So you can really guide that process and really give them piece by piece more things they can do in a DSL. So as soon as you find that you can trust your domain experts with certain expressiveness, you can also give them that expressiveness in a very controlled way without things blowing up right away. Okay. So there's also a couple of challenges with projectional editing, apart from getting demos to work, etc. There's a limited number of tools and frameworks for this. For textual DSLs, like just Google ones, and you have a million of them. For projectional editing, it's just a couple of them. So JetBrains MPS is basically by now the grand dame of projectional editing. A fairly new one is Freun, and you probably know Blockly, Google's Blockly, used for Scratch or Scratch type languages. Those are also frameworks to make DSLs with. Another challenge you have with projectional editing is expressions. We are very used, even non-developer people, we are very used to typing in expressions. And that works perfectly well, or quite well, for textual DSLs. But it's more of a challenge for projectional DSLs, projectional editing-based DSLs. That's not entirely the fault of projectional editing, it's just that we grew accustomed to typing expressions. But if you think about it, typing expressions is also quite intricate, because you have to be aware of, for example, priorities, operator priority, precedence. So just typing in stuff also does stuff. And if you remove some parentheses here and add a plus there, etc., you're not guaranteed with a textual DSL that your expression actually makes sense, that it would actually parse, and the meaning can have changed quite a bit with very subtle changes. So expressions in general can be quite challenging. Another thing is that because your AST is your truth, you have to serialize it at some point. You have to store it somehow, and that's not going to be a nice textual representation of your AST, but just, for example, JSON or something like that. So if you want to do software developer process kind of things like diffing, review process, etc., you need to do a bit of extra work to make these differs that work for your projections. Yeah, so a couple of examples of these frameworks for projectional editing. MPS from JetBrains is one of them. As you can see, you can make quite nice projections with them, quite nice notations with them. Freun is another one. One of the fathers of OCL is making that one, and that's really a very modern one. Blockly already mentioned, and I'm myself working with a couple of people on LionWeb, which is not a framework for projectional editing as such, but it is very projectional editing friendly. Let's put it this way. So, and I don't know if anyone ever used EMF, something like that. No EMF users here. I see some sour faces. Like, was painful. Okay, so LionWeb is more or less EMF, but then as JSON and without the sour face and all the pitfalls and pains of EMF. So it's a way to represent DSL content or models, if you want to call them like that, and to be able to exchange that DSL content across components and environments. So my conclusion is, please go out and craft the DSL using projectional editing for your business domain expert. They will definitely love you for that if you do that. So, any questions? This would normally be the point where I would start saying things like, "If you have a very good question, I will give you a book, namely my book, a copy of my book."
Yeah, thanks, Mainte. Any questions?
So you mentioned some issues with parsing. You mentioned lag factoring, which means like using some kind of tooling. My hot take is that using tooling to go from grammars to parsers produces terrible error messages and everything.
Yep.
What is your approach to parsing? What do you use?
Well, I don't use any parsing. I don't make parsers myself anymore. I don't make grammars anymore. So the whole thing with projectional editing is because you start with, I want to have an AST. You can just start with, okay, what are good types for that? For example, well, yeah, what are good classes for that? Eh? What's a good class hierarchy to represent my DSL content? So what's a good structure for my DSL? And I don't have to think about, oh, but I have to make a grammar. So I start with a grammar, and then I have to do certain things to the grammar to make to generate a parser that actually parses the language that I want. I think you're very familiar with that cycle of tweaking your grammar so that what you want to express is actually parsable. So with projectional editing, you just start really the other way around. You have your structure, then you write this projection function, basically, which produces this projection, the projected AST, and that is all that your domain expert will see, and you don't have to parse anything anymore because you just change the AST in the end.
So my background is mostly like with type systems and formal verification, and it seems to me that these specific languages are like a very good opportunity to like capitalize on that. Let's say, so basically, like to ensure that every constructed like program in one of such languages is always like correct and under certain definition of like correctness and stuff, especially due to like the smaller size of like most DSLs, I guess.
Yeah, that's an interesting point of view. I think what we as developers are not always aware of that if we do some kind of DSL, some kind of languagey thing, the AST, whether we arrive at it via parsing or we use projectional editing, will be in a faulty state 95% of the time because you're editing it. So it will always be incomplete or there will be some error. So this, I think something like type systems and constraints, etc. They tend to come into play with projectional editing only a little bit later because you're basically editing the AST directly through a nice projection. So your AST will be much more correct for more of the time than with parsing, where you have to sometimes do something, a lot of things with type systems, etc., to even know that your AST is correct enough to do something with that.
think that due to like the constraints of the domain and stuff, it will be like easier, for example, to formally verify programs in like domain-specific languages or.
Yeah. So that's going a little bit into the realm of the meta part of this, obviously. You tend to need much fewer constraints for DSLs than you would need you would need much fewer constraints for projectional editing-based DSLs than you would need for parsing-based DSLs in general. So you can also reason about that a little bit better. And for example, what a tool like MPS does, MPS has a couple of meta DSLs, and one of them is for defining constraints. So you can also reason about that more. So indeed, formal verification of your language will be of your language itself. Your implementation will be much more viable than for general programming languages, where we know it's a darn hard problem.
Thank you.
So I thought I think DSLs work really well when you have a good idea of what your business domain is, right? But what if your employer has a little more of a vague idea of what you're supposed to be doing? How would you start going about making DSLs then?
Usually, your employer has absolutely minus 9,000 idea about that a DSL is a good idea for them. So that's a bit of a challenge. I mean, if you go out there and you look at job openings, for example, language creator or DSL creator or DSL implementations, there are just none. So I get my work from my network. So as soon as I have some work, then if I have somewhere a job, then indeed the first thing I need to do is talk to people. First, get a good idea of what is the domain, what is the scope of it, what are the domain experts, what are the stakeholders among them, what are the most important domain experts among them. Talk to them, and then slowly extract or chisel out first a small DSL and then build from there. So it's really an incremental process with a lot of talking. The upshot is that I only need to do that once, so to speak. Because in a normal project, you have a lot of software developers working on that domain, and they all need to learn that domain, right? And with this approach, if you make a DSL, ideally one meta developer has to learn the domain and then craft a DSL for it. And then the domain experts can do the programming themselves, so to speak. So it's also on that side. It's quite a bit more efficient, and it's also a lot more fun than. I mean, we've all been in projects where we had to add a field to a screen, and then you also had to adjust the class for it, and do something with database queries, and put an extra row in or extra column in a database table, and stuff like that, and that times 100. I mean, that's no fun. This work is much more fun to do.
Okay, more questions?
So the DSLs that you created, are they for specifying algorithms or also for data structures, for databases, for data representation?
Easy answer, yes. Like all of them. So, for example, this regelspraak, this rule speak at the tax office, it's a declarative language, right? I mean, it just says, in this kind of situation, this has to happen. But in the end, it's also an algorithm specification, because there is a deterministic path from going from the input through those rules to an output. So that's also an algorithm specification. It's actually one of the other DSLs in this tax agency tooling is gegevensmodel, which is a data structure definition language, because you also have to specify, okay, what shape can my input have? So usually it's a couple of those aspects at the same time, which also gels perfectly with this idea of the vertical domain, because DSLs tend to work very well for vertical domains because they just cross-cut through all these technological layers, these horizontal layers in your technology. So that's why it's perfect to have like a small DSL for your data definition, and then have business rules that refer to that data model that you can specify with that and work on that. So yeah, short answer, yes, algorithm specification, data structure definition, etc. Even up to even things like layouts and things like that.
Okay, thanks, Meinte. Another applause for Meinte.